It begins with a silence too deep to be measured, a hush stretched across the fabric of the cosmos, until suddenly something crosses the threshold. An unfamiliar streak of light, faint yet undeniable, slides into the solar system from the abyss beyond. This is no ordinary wanderer, no comet bound to the sun's pull, no asteroid born from ancient collisions. This is 3I Atlas, the third confirmed interstellar object ever glimpsed by human eyes. It carries with it not just dust and ice, but an air of rebellion, as if it was sculpted in defiance of the laws that govern planets, moons, and stars. The object did not ask for permission. It did not warn of its arrival. It simply appeared, like a whisper from the deep night, its path already betraying origins in another system, another sun, another history written light years away. To see it was to feel a tremor in our understanding, for its trajectory was hyperbolic, an orbit that could not be captured, a journey that could never circle back. It was a trespasser, here for but a moment, then gone again into the dark. Scientists had long anticipated such visitors. Oumuamua had been the first, a herald of mystery in 2017, followed by the comet Borisov. But Atlas was different. Its faint shimmer, its velocity, its stubborn refusal to fit neatly into established categories all pointed to a story still unfolding, one that would push the boundaries of physics itself. Was this a fragment torn from an alien star system, hurled outward by the collapse of some distant world? Or was it something stranger still, an emissary of forces not yet mapped, not yet dreamed of, lurking in the hidden equations of reality? For those who first turned their telescopes toward it, Atlas was not just a discovery, it was an omen. Its very presence suggested that the universe may be far less obedient than our laws of motion, gravity, and thermodynamics demand. It was as if the cosmos, with quiet confidence, had sent a reminder: human understanding is still young, and not all travelers play by rules. The memory of a prior visitor still lingered when Atlas arrived, an echo carved into the scientific imagination by the strange silhouette of 2017's most enigmatic intruder, 1I Oumuamua. That name alone still conjures images of bewilderment, a shard of another star system tumbling silently past Earth, sparking debates that raged from sober academic circles to late-night speculation of alien technology. Oumuamua had been humanity's first glimpse of the interstellar unknown, and it had changed everything. The discovery had unsettled astronomers not only because of what it was, but because of what it refused to be. Oumuamua bore no tail like a comet, yet its trajectory hinted at unseen forces nudging it off course. Its brightness flickered in ways that suggested a shape elongated, almost unnervingly artificial, as though nature had sculpted it into a cigar or a flat disc. For months, telescopes pursued its faint trace, but it slipped away too quickly, leaving only puzzles and arguments in its wake. Some invoked jets of sublimating ice, others hinted at thin sheets of exotic matter, while a few more daring suggested a probe crafted by distant intelligence. By the time 2Y Borisov appeared in 2019, the story had shifted. Borisov behaved more like a conventional comet, trailing gases and dust in patterns familiar to planetary scientists. It soothed the tension left behind by Oumuamua, reminding astronomers that the interstellar void could also cast forth the ordinary. Yet in that same reminder was an omen. If one interstellar body could arrive every few years, then countless more must wander between the stars, awaiting detection. And then came Atlas, where Borisov had been familiar and Oumuamua unsettling. Atlas was something else entirely. Its behavior, at first glance, whispered similarities to both, but beneath the surface, its identity refused to settle. It carried a faint glow, yet not one that matched the sublimation patterns of comets. Its orbit was unambiguously hyperbolic, more extreme than either of its predecessors, its path carved as though it had been flung with deliberate force. And its velocity swift, relentless, seemed almost eager to escape the sun's pull, even as it grazed our celestial neighborhood. For scientists, the comparison was irresistible. Was Atlas a sequel to Oumuamua, another messenger meant to bend our sense of cosmic normality? Or was it an entirely different class of object, born of processes beyond what the solar system could teach? To frame Atlas was to revisit the strangeness of its predecessors, and to realize that the universe was not merely sending curiosities, it was sending questions, each more insistent than the last. Where Oumuamua had invited speculation, Atlas demanded confrontation. It did not just remind us of how little we knew, it dared us to admit that the rules we trusted might be fragile, provisional, and incomplete. And in that dawning realization, scientists sensed both excitement and dread. This was no isolated anomaly. It was the opening act of a much larger, cosmic narrative. The first sighting was faint, so faint that most telescopes would have ignored it had it not moved against the fixed stars. Through the long, patient exposures of wide-field surveys, astronomers noted a delicate streak, a smear of light barely above the noise of the background sky. It was March, and the Pan-STARRS Observatory in Hawaii, its lenses sweeping the heavens as part of a constant vigil for near-Earth objects, caught the ghostly trace. At first glance, it seemed like any other cometary detection, a dim intruder, perhaps shedding dust, perhaps destined to brighten, yet something felt different. The astronomers, accustomed to the quiet rhythm of cataloguing countless minor bodies, began to plot the new object's course. Computers churned orbital solutions, turning faint dots into trajectories. What emerged was not the familiar curve of an elliptical orbit, nor the bound arc of a long-period comet. Instead, the numbers painted a path unbound, a trajectory that came not from the sun's embrace, but from the far abyss. The orbital eccentricity was greater than 1, an unmistakable signature of the interstellar. The observatory staff marked it, cross-checked the data, and sent alerts through the global networks that link telescopes from Earth to space. Professional astronomers in Chile, Spain, and Arizona turned their eyes to the same coordinates, each confirming that something truly extraordinary had arrived. Unlike most discoveries, which unfold gradually, this one revealed its strangeness immediately. Its brightness was inconsistent, its movement sharper than expected, its spectral lines whispering of unusual composition. The first glimpses spread quickly through the scientific community. Astronomers described the newcomer with both caution and awe, its provisional designation tied to the Atlas survey that had confirmed its trace. The faintness was a curse. The object was already fading even as telescopes locked onto it. Every night mattered. Every additional data point was a desperate attempt to hold onto a visitor that was here only briefly, racing toward its inevitable disappearance. For those who first glimpsed Atlas, it was as though the sky itself had shifted. The familiar heavens, mapped for centuries, had been pierced by an uninvited emissary. Unlike planets, unlike comets, unlike asteroids, this was a traveler whose home was not here. And that single fact, revealed in the subtle tilt of its trajectory, carried the weight of something immense, a confirmation that the interstellar gulf is not empty, that fragments of alien systems slip between stars and into our gaze, and that the solar system is not isolated, but open, porous, and vulnerable. The telescopes had not only glimpsed a streak of light, they had glimpsed a question. What world, what system, what unimaginable cataclysm had flung this body across the void? And more troubling still, what did its very presence mean for the stability of the laws that bind our cosmos together? As the orbital solutions grew sharper, the truth emerged with unsettling clarity. 3. I Atlas was not bound to the Sunday. Its path carved a hyperbolic arc, one that entered from the outer dark and would, in due time, leave again, never to return. In celestial mechanics, such an orbit is a signature of exile, a testament that this traveler was born under another star, flung free from its cradle by forces unimaginable. For the first time, astronomers could declare with confidence that Atlas was a true interstellar messenger, a shard of distant creation passing briefly through our neighborhood of space. The mathematics told a story as ancient as it was violent. To acquire a velocity great enough to break free from the gravity of its parent star, Atlas must have been thrust outward by a collision, a planetary migration, or perhaps the chaotic dance of multiple suns tugging at one another. Somewhere in the long history of its home system, catastrophe had shaped its fate. And for eons, millions, perhaps billions of years it had drifted between stars, untouched, unaltered, until chance aligned its trajectory with our solar system. The confirmation of its hyperbolic orbit was met with awe. This was not speculation, not a fleeting suspicion like so many anomalies in astronomy. This was precise, measurable proof. The eccentricity of its orbit exceeded one. No solar system comet, however distant, could mimic such a path. Atlas was not ours. It belonged to the galaxy. But if the mathematics offered certainty, the implications offered only unease. For in its path lay hints of strangeness beyond exile. The hyperbolic trajectory was steeper than expected, sharper, as though the object carried a hidden momentum. Its velocity, calculated as it swung near the Sun, exceeded predictions drawn from gravitational models. Something more than Newton's gravitation, more than Einstein's curvature of space-time, seemed to be at play. The interstellar signature, once a triumph, soon became a puzzle. Why did its path deviate? Why did its light flicker in ways that suggested shapes and rotations alien to comets and asteroids alike? Why did its faint chemical signals whisper of ices unseen in the solar system? The confirmation that Atlas was interstellar did not end the story. It was the beginning. Astronomers understood what this meant. Each interstellar visitor was more than just a rock. It was evidence of the galaxy's hidden architecture, fragments of distant worlds wandering freely, carrying secrets of physics and chemistry beyond our reach. Atlas was a message written in orbital mechanics and spectral light. And as it slid silently through the solar system, its hyperbolic orbit seemed less like a trajectory and more like a question mark etched across the heavens. Speed is a language of its own in the cosmos. Every planet, every comet, every mote of dust around the Sun is bound by velocity, a delicate balance between gravity's embrace and inertia's desire to flee. To orbit is to be held, to fall forever without escaping. But 3I Atlas carried with it a different rhythm, one that defied the quiet harmony of the solar system. When its motion was charted against the stars, its speed startled astronomers. At perihelion, the point of closest approach to the Sun, it surged faster than the escape velocity of our system. Where an ordinary comet or asteroid could only linger within the Sun's dominion, Atlas moved as if impatient, as though compelled by some unseen hand to continue outward into the abyss. Its hyperbolic trajectory guaranteed it was unbound, but the numbers revealed something more, an energy surplus, a momentum that seemed excessive even for an interstellar refugee. This velocity was not simply high, it was extraordinary. By comparing its inbound and outbound speeds, scientists noticed a subtle discrepancy. The object did not merely fall inward under the Sun's gravity and rise again with equal measure. Instead, it departed with an acceleration that resisted easy explanation. Had some sublimating gas thrust it forward, as with certain comets? Or was there a deeper mystery at work? an interaction unseen yet undeniable. The enigma of speed is not just mechanical, it is existential, for to move faster than expected is to hint at hidden forces, at energies not accounted for in the cosmic ledger. And in Atlas's case, the discrepancy raised the spectre of laws bending. Was this a relic of the dark sector, infused with exotic matter that interacts differently with gravity? Was it a shard flung from the turbulence of another galaxy, carrying momentum impossible to replicate in ordinary stellar systems? Einstein's equations of relativity had long governed our understanding of motion at cosmic scales, weaving together velocity, time, and gravity into a seamless geometry. Yet here was an object whose flight seemed to mock the elegance of that tapestry, as if it were tugged by a thread invisible to all instruments. The unease deepened. Perhaps Atlas was not merely fast, but impossibly so. In its passage, humanity glimpsed not only a traveler, but a rebel. Atlas raced past, unyielding, as though to remind us that the universe is not bound by our comprehension, that velocity itself may conceal secrets not yet written in any textbook. And in that realization, scientists felt both exhilaration and dread. To chase such speed is to chase the edge of physics itself. Light became the only language left to decipher Atlas, and its flickering betrayed a story stranger than expected. As telescopes tracked its passage, astronomers measured the variations in its brightness, the subtle pulses as the object spun and reflected sunlight. Ordinarily, such light curves reveal shape and rotation, allowing scientists to infer whether a body is spherical, elongated, or tumbling chaotically. But Atlas refused to play by those rules. Its brightness shifted in irregular patterns, inconsistent with simple geometries. At times the object appeared stretched, elongated like a shard of fractured glass. At others it hinted at a flatness, as though it were a thin disk twisting in the light. No stable model seemed to fit. Some scientists suggested it was a fragment breaking apart, shedding pieces too small to see yet altering the light we received. Others argued it must be rotating in an exotic, chaotic spin state, never settling, never repeating. Yet even those explanations left something unresolved. The intensity of its fluctuations suggested angles and reflections sharper than natural comets or asteroids usually provide. Some whispered that its geometry might be alien to solar system processes altogether, born of a chemistry or physics unlike any we have studied. If so, then the object was not merely a rock from afar, but a relic of alien creation, shaped in environments our models have never considered. The irregular shadows were unsettling because they recalled an earlier mystery, the bizarre light curve of Oumuamua. That first interstellar visitor had also defied shape analysis, its brightness swings implying a geometry far too extreme for familiar bodies. Atlas, though distinct, seemed to echo that enigma, as if interstellar travelers shared a tendency to violate our expectations of form. For scientists, shape is more than appearance. It is the fossil record of formation. Planets and asteroids bear scars of their histories, their collisions, their gravities. To see a body that refused to fit was to stare into the face of an unknown history. Was Atlas once part of a shattered planet, flung outward in a cataclysm? Was it a shard carved by exotic ices melting away in some foreign system? Or was it something stranger, an object shaped by processes beyond natural mechanics? The shadows it cast were not only on the sky, but on the mind. Atlas was not merely a visitor, it was a puzzle in silhouette, its geometry a quiet rebellion against the familiar. And in those shifting shadows, the question deepened. If its shape was alien, what of the laws that shaped it? Light does more than reveal shapes. It carries whispers of chemistry, signatures etched into the spectrum of starlight reflected and absorbed. When scientists turned their spectrographs toward 3I Atlas, they sought the familiar fingerprints of comets, water vapor, carbon dioxide, cyanide, dust. Instead, what returned was something both subtle and strange. The spectra hinted at volatile compounds, but not in the ratios seen in solar system comets. Water ice, so dominant in local wanderers, seemed faint, even reluctant to appear. Instead, the light betrayed traces of carbon-rich molecules and exotic ices that formed only under conditions far colder, far darker than the environments of our system. The signature suggested an origin where the parent star cast little warmth, perhaps a red dwarf with a frosty circumstellar belt, or even a system where interstellar radiation sculpted matter differently. There were peculiar absences too. Elements expected in ordinary cometary bodies were muted or missing. It was as though Atlas carried with it the imprint of another chemistry, a recipe written under alien rules. To astronomers, these faint chemical differences were as startling as its orbit. For chemistry is the language of formation. It tells of the cradle in which a body was born. And here, the cradle was unrecognizable. The gases observed did not behave predictably either. Atlas shed material, but unevenly, in ways that did not conform to standard cometary activity. Jets of sublimated gas would explain some pushes and flickers of light, but the distribution seemed chaotic, as though the object was stitched together by fragile seams now unraveling under solar heat. If it was disintegrating, it was doing so unlike any comet known. This difference raised deeper questions. Was Atlas perhaps an ancient fragment, its chemistry altered by countless millennia adrift in interstellar space, bombarded by cosmic rays? Could it even contain molecules forged in environments our solar system never knew, complex organics formed in the dense molecular clouds where stars are born? If so, then Atlas was not merely a visitor, it was a messenger, carrying alien chemistry into our sky, a tangible relic of processes beyond Earth's reach. The strangeness of its spectrum reminded scientists of a humbling truth. Chemistry, too, may not be universal. What we call normal may only be local. In the faint gases of Atlas shimmered a possibility that matter itself might tell different stories when shaped under different suns. And that realization was both thrilling and unsettling, for it meant that even the simplest substances, ice, gas, dust, could remind us how provincial our understanding still is. The further astronomers traced Atlas's path, the more unsettling the numbers became. Orbital mechanics is usually a language of precision, its equations tested for centuries, its predictions able to guide spacecraft across billions of kilometers with pinpoint accuracy. Yet here, within the data of this faint interstellar visitor, something refused to align. The orbit bent in ways unaccounted for, deviating subtly but persistently from what pure gravity should dictate. In classical terms, every body moving through the sun's field follows a trajectory determined by mass and momentum alone, but Atlas seemed to carry an invisible companion, a hidden force that nudged it off its expected course. These were not wild leaps but delicate shifts, a slow divergence that accumulated into a mystery. For scientists, such small anomalies often matter. Most tiny deviations have been the seeds of revolutions, from the discovery of Neptune to the dawn of relativity. The possibility of sublimation jets, plumes of gas thrusting from beneath the surface, was raised immediately, echoing the explanations once tied to Oumuamua. But once again, the evidence refused to cooperate. The chemical traces were too faint, the jets too irregular to fully account for the sustained push required. Something else seemed at work, something not reducible to frozen water hissing into space. If not sublimation, then what? Some speculated exotic ices, releasing energy in forms not yet modeled. Others whispered of interactions with solar radiation unlike those seen before, perhaps involving molecular structures more efficient at capturing and redirecting light's momentum, and still others, daringly, suggested forces more profound, the influence of dark energy at a local scale, the tug of space-time distortions, or relic effects from the quantum vacuum itself. The phrase repeated across conferences and papers was the same. The laws seemed bent, not shattered outright, but flexed, strained at their seams. Atlas was not a comet behaving badly, nor an asteroid in disguise. It was something that walked the line between categories, mocking the taxonomy of astronomy. And the deeper implication was chilling. If the orbit of a body could not be fully described by Newton and Einstein, if every explanation stumbled against missing evidence, then perhaps we were staring at the limits of our own physics. Atlas's path was more than a curve through the sky. It was a question drawn against the canvas of space-time, daring humanity to admit that its cherished laws may be local conveniences, not universal truths. Trajectory is destiny in celestial mechanics, and yet 3I Atlas carried a path that seemed haunted. When astronomers recalculated its position night after night, the orbit refused to settle, as though something unseen tugged at it from the darkness. These deviations were small, often buried in the uncertainty of faint data, yet persistent. The object seemed to drift where no visible force guided it. It was as though a ghost traveled alongside, invisible but insistent. The suspicion of gravitational ghosts emerged quietly, first as murmurs in research notes, then as louder speculation at conferences. Could Atlas be interacting with something we could not see, an unseen companion body, a pocket of dark matter, or even ripples in space-time itself? The solar system is vast, and though its major players are charted, subtle masses may linger undiscovered. Perhaps a dense fragment of rock, too dim to reflect sunlight, lurked nearby, pulling gently at the traveler. Yet the pattern of deviation did not match such a neat cause. Instead, it evoked something stranger. Some physicists wondered if local space-time might not be as smooth as Einstein's equations assume. Could Atlas be drifting across subtle gradients of gravity, wrinkles of curvature unaccounted for by our models? Or might it be sensitive to interactions that ordinary matter ignores, responding to fields we have not yet detected? The idea was unsettling, that an interstellar shard, hardened by eons in alien environments, might reveal interactions invisible to our parochial instruments. Others whispered darker possibilities. If dark matter is indeed scattered through the galaxy, then Atlas may have brushed against a clump, invisible yet massive enough to shift its course. To us, such matter is a phantom, detected only by its gravitational pull on stars and galaxies. Could this small anomaly be a glimpse of the dark sector intruding at a local scale? The phrase, invisible interactions, clung to the debate. They were not proven, but neither could they be dismissed. The data pointed to a presence we could not weigh, could not see, could only infer. For scientists, this was both tantalizing and terrifying. The cosmos might be littered with hidden forces, shaping trajectories in ways too subtle for our equations to capture. And so Atlas became more than a comet or fragment. It became a ghost detector, an unwilling probe sent from afar, tracing the contours of space-time with its path. Its orbit was a message written in deviations, its silence louder than explanation. To follow it was to follow a shadow, a reminder that the universe may be more haunted than we dare to imagine. Einstein's equations have long been the compass by which humanity charts the heavens. His general theory of relativity bends light around stars, predicts the slow precession of planets, and explains the invisible wells of gravity where black holes reside. It is the framework through which space-time itself is understood, woven with mathematical precision into the fabric of modern science. Yet 3I Atlas, seemed to dance on the margins of this structure, as though reluctant to obey the very rules that bind galaxies together. When astronomers compared its observed trajectory with predictions drawn from relativity, unease crept in. The deviations were not spectacular crashes of certainty, not the outright breaking of equations. Instead, they were whispers, nudges that hinted the universe was not quite as smooth, not quite as predictable as the field equations demanded. For relativity, the smallest cracks matter most, because they point toward places where the theory might be incomplete. Einstein himself had known that his equations, however elegant, were unfinished. He sought a grand unification, a framework that would reconcile gravity with quantum mechanics. In the century since, that search has continued, and every anomaly is a potential doorway. Atlas, with its stubborn refusal to fall exactly as it should, became one such doorway. Was this a sign of unseen forces within space-time, tiny distortions that relativity could not resolve? Or was it evidence of a material body infused with properties unknown, carrying the scars of another universe's physics? For many, to suggest relativity could be tested by a lone shard of rock seemed almost blasphemous. The theory had survived eclipses, pulsars, and gravitational waves. Yet, the cosmos has a way of sending challenges in humble packages. Atlas, faint and fragile, carried with it a reminder. Even Einstein's towering vision may be only a chapter in a larger, unfinished book of nature. And so, in the quiet halls of observatories, the question lingered. Was Atlas a mere comet, behaving oddly? Or was it a messenger hinting that the universe was deeper, stranger, and less obedient than Einstein imagined? The smile or frown of relativity itself seemed to hover over its path. There is a shadow stretching across modern cosmology, one that has haunted every measurement of the universe's expansion: dark energy. First revealed in the late 1990 seconds, it is the name we give to the unseen force accelerating the cosmos outward, driving galaxies apart faster and faster as time flows on. For decades, it has been a mystery relegated to the vast scale of the universe itself, a whisper heard only in the redshift of distant supernovae and the cosmic microwave background. But with Atlas, some began to wonder, could the fingerprints of dark energy appear on a much smaller stage? Its unexplained acceleration, its refusal to follow Newton and Einstein precisely, called forth dangerous speculation. Perhaps Atlas, a wanderer forged in alien conditions, was sensitive to the hidden field of dark energy. Maybe its very structure responded to a force too subtle for our instruments, but strong enough to nudge its path over astronomical distances. If true, then the object was not merely an interstellar fragment, it was a test particle of the unknown, a natural probe sent to us across the void. This was not idle musing. Some physicists have long argued that dark energy, while weak, may ripple into local scales through quantum effects, its presence shaping matter in ways we cannot yet predict. Could Atlas have been dislodged from its home star not just by gravity, but by the restless vacuum itself? Its hyperbolic path, its surplus of speed, its delicate deviations all seemed to echo the same invisible hand that stretches the universe itself apart. Such ideas are perilous, for dark energy is already a placeholder term for ignorance. It is the name of an equation's remainder, the unknown in a cosmic sum. To suggest it acts upon a wandering shard risks extending speculation into myth, yet the question was irresistible. If Atlas bore the influence of dark energy, then humanity had, for the first time, touched the edge of the force shaping the entire cosmos. And so, whispers arose in the scientific conversation. Was this faint traveler a messenger of the same mystery that defines the universe's destiny? Could a fragment of ice and dust carry with it proof of the power that drives galaxies apart? Atlas became more than a comet. It became an echo of the acceleration of reality itself, a reminder that even the smallest shard may carry the weight of the infinite. The search for an explanation turned inevitably toward the familiar. When comets stray near the sun, they awaken. Their frozen cores, once dormant, heat and fracture, releasing jets of gas that act like unseen thrusters. These sublimation plumes can alter a comet's trajectory, bending its path in ways that mimic gravitational anomalies. With 3I Atlas, many astronomers hoped for the same answer, a simple, natural mechanism to rescue physics from the brink of contradiction. The phantom jet hypothesis grew quickly. Perhaps Atlas was riddled with volatile ices, ancient compounds long buried beneath its surface. As the sun warmed it, these ices could erupt in asymmetric streams, pushing the object slightly sideways, forward, or backward. Such jets would explain the small but persistent deviations from the predicted orbit. In principle, this was a comforting solution. It kept the mystery grounded in known cometary behavior, no need for exotic forces or broken laws of physics. But as the data piled in, comfort gave way to doubt. The spectral readings of Atlas revealed only faint traces of typical cometary gases, far too weak to sustain the necessary thrust. The light curves suggested instability, yes, but not the repeated rhythmic bursts expected of jets. And most troubling, the direction of the supposed acceleration did not always align with where sublimation would naturally occur. The numbers resisted the neatness of the explanation. The debate split the community. Some clung to the jet model, insisting that the data was simply too thin, that faint plumes might still account for the anomaly if hidden beneath observational noise. Others, more daring, argued that the persistence of the acceleration pointed beyond sublimation entirely, toward forces unfamiliar to solar system science. This tension echoed the earlier debates over Oumuamua, where the absence of a tail yet the presence of a push had confounded explanation. Atlas seemed to repeat the riddle. If jets existed, they were invisible. If they did not, then something unearthly was at work. In the silence of these contradictions, the object itself seemed to mock our models. To call it a comet was to stretch the word into unfamiliar territory. To call it an asteroid was equally false. And so it became something else. A phantom between categories, its thrust invisible, its explanation elusive. Atlas, in this sense, was not just breaking laws, it was testing the resilience of human imagination, daring us to ask whether our explanations were themselves jets of comfort, pushing us away from the abyss of the unknown. The deeper astronomers peered, the more they found themselves at a crossroads where theories collided rather than converged. Each explanation carried a fragment of plausibility, yet none stitched the whole. Atlas became a battlefield of models, each incomplete, each straining under the weight of contradiction. The comet hypothesis remained the most conservative, a body of volatile ices fractured by the sun's heat, its anomalies explained by sublimation jets too faint to be seen. But this model bent under the burden of missing chemistry, absent water vapor, and inconsistent acceleration. If Atlas was a comet, it was one unlike any seen before. The asteroid model offered another path, a rocky fragment flung free from a distant planetary system, barren and airless, its strangeness owed to unfamiliar mineralogy. Yet its fading glow, its whisper of volatiles, contradicted such dryness. It was too alive to be purely stone, too faint to be merely ice. More speculative voices invoked the extraordinary. Some likened Atlas to a quantum relic, matter shaped in the earliest moments after the Big Bang, infused with properties unknown to contemporary physics. Such an object might carry anomalous inertia, or respond subtly to cosmic fields we cannot yet measure. Others dared to wonder whether it was engineered, a fragment of technology or probe, deliberately crafted to survive eons of interstellar flight. Its odd acceleration, not an accident but intention. This possibility, however fringe, carried echoes of the debates surrounding Oumuamua, when a handful of scientists suggested that the object's odd trajectory might betray alien design. Atlas, too, fed such whispers, if only because natural models stumbled. Was it arrogance to dismiss such speculation, or desperation to accept it? Yet still more radical hypotheses surfaced. Perhaps Atlas was neither comet nor asteroid, neither relic nor craft, but something we lacked words to classify, a shard of a planet torn from its star and crystallized under alien suns, or even a fragment of exotic matter, stabilized by physics we have not yet learned. Each theory glittered with possibility, but each fractured under scrutiny. The collisions of theory revealed something larger than Atlas itself: the fragility of our categories, the narrowness of definitions forged in one solar system. For here was an object that refused to be named, to be contained. It was not a comet, it was not an asteroid, it was not alien technology, nor was it entirely natural as we know it. It was all of these at once, and none of them at all. And in this storm of theories, scientists were forced to confront an unsettling truth. Sometimes the cosmos delivers mysteries that cannot yet be solved, only endured. Atlas was such a mystery, a mirror reflecting not answers, but the fractures in human understanding. When reason falters, imagination reaches further. For some, the mystery of 3I Atlas was not merely chemical, mechanical, or gravitational, it was existential. Its refusal to conform to the ordinary laws of comets and asteroids led a handful of theorists to suggest something bolder. What if Atlas had not only crossed space, but boundaries between universes? The multiverse hypothesis has long existed on the fringe of cosmology, a speculation born of inflationary theory and the mathematics of quantum fields. It suggests that our universe is but one bubble in an endless foam, each governed by its own constants, its own physics, its own destinies. If so, then the seams between universes might, on rare occasions, leak. Could Atlas be such a leak? A fragment of matter birthed in another cosmos, wandering here through an opening invisible to us. The anomalies seemed to fuel the idea. Its unexpected acceleration, its unearthly chemistry, its defiance of classification, all might be consistent with matter sculpted under rules not identical to ours. Perhaps it carried with it a geometry alien to Einstein's space-time, or elements stable elsewhere but unstable here. Perhaps even its speed was the legacy of a physics that did not emerge in our universe at all. Though mainstream astronomers remained cautious, the philosophical allure was undeniable. Atlas, as a multiversal shard, cast humanity in a new light, not merely a species peering outward into space, but one brushing against the edge of reality's fabric. To contemplate such origins was to realize that the mystery might not be what Atlas was, but where it was truly from. Skeptics dismissed the notion as romantic excess, yet even they could not deny the seduction of the thought. The multiverse had always been a mathematical ghost, untestable, abstract. But here was a body, real and measurable, defying classification. Could it be the first tangible clue that universes bleed into one another, that the cosmos is not singular but infinite, endlessly varied? Atlas shimmered in the telescopes like a reminder of how little we know. To imagine it as a messenger from another universe was to embrace speculation at its grandest, but also to confront a haunting possibility that the laws of physics we cling to so tightly may not be universal at all, but provincial truths of our own bubble, fragile and local. If Atlas was not born of another universe, perhaps it was born of another time. the possibility emerged in hushed tones that this body might carry within it the memory of physics older than the stars, a fossil not of geology but of cosmology itself. Astronomers began to ask, what if Atlas had been shaped in the crucible of the galaxy's earliest moments, when the universe was less than 1 billion years old? The chemistry hinted at extremes ices that formed only in the deepest cold molecular signatures alien to our solar system. Could it have been forged before the familiar elements had settled into their modern balances, before countless cycles of star birth and death enriched matter with heavy atoms? This line of thought led inevitably to the realm of relic particles, survivors from epochs when the laws of physics themselves were fluid. Cosmologists speak of eras: the inflationary burst, the quark-gluon plasma, the recombination of electrons and protons, each left behind relics, neutrinos still streaming unseen through our bodies, background radiation filling the sky. Might Atlas itself be such a relic, a macroscopic shard bearing the imprint of quantum conditions long gone? If so, it could hold within its structure clues to forces we only theorize: dark matter interactions, exotic states of hydrogen, or molecular patterns shaped by the earliest cosmic rays. In this view, Atlas was less a comet and more a time capsule, a memory of the universe before planets, before galaxies matured, before even gravity had taken its familiar form. To study it was to brush against deep time, to imagine matter carrying whispers across billions of years. Perhaps its anomalous acceleration was not an active force at all, but a passive property of ancient physics, a resonance with fields that no longer exist in our epoch. If true, then Atlas was a messenger not only from afar, but from the dawn itself. This possibility weighed heavily on scientists, for if the object preserved the memory of physics older than our stars, then to lose it, to watch it fade into the void, was to let slip an irreplaceable record. Humanity had, by chance, been handed a shard of the universe's forgotten childhood, and yet, like Oumuamua before it, Atlas would soon vanish beyond reach, carrying its secrets back into silence. It was a reminder, as humbling as it was haunting. The cosmos is ancient beyond measure, and within it may drift bodies that remember laws of nature we no longer see. Atlas might be one such memory, a silent witness to the infancy of reality itself. Telescopes strained against the abyss, chasing a fading ember across the sky. For all its strangeness, Atlas was faint, so faint that every night of observation risked being the last. The great instruments of Earth turned toward it in unison: the Keck Observatory atop Mauna Kea, the Very Large Telescope in Chile, arrays of radio dishes, and even the Hubble Space Telescope above the atmosphere. Each was tasked with capturing whatever light it could, siphoning whispers from a vanishing ghost. The problem was not only distance but time. Interstellar visitors move swiftly, their paths slicing through the solar system with indifference, leaving only weeks or months for study. Unlike planets or comets that circle back, these bodies pass once, then vanish forever. Atlas, like its predecessors, was already receding into obscurity, its trajectory uncatchable by spacecraft, its glow dwindling with each passing hour. Data streamed in: jagged light curves, faint spectra, marginal detections of gas. Scientists built models, but the models strained under the weight of uncertainty. The object seemed always just beyond reach, too dim to resolve clearly, too fast to linger, too alien to categorize. It was as though nature had placed a treasure before us, but veiled it in shadow, daring us to glimpse only fragments. Instruments reached their limits. Even the most sensitive detectors struggled to hold the signal above background noise. Observers fought for telescope time, knowing that every competing target stole precious hours from Atlas. The urgency was palpable. Once lost, the object would never be seen again. The frustration was not new. Humanity had missed its chance with Oumuamua, gathering only a handful of observations before it slipped away. With Borisov, the clarity of a comet had comforted us, but offered little mystery. Atlas was different. It demanded answers, yet refused to yield them, fading too quickly for the instruments of today. The silence of its departure carried a bitter truth. Our technology, though vast, is still fragile before the speed of the universe. We can glimpse interstellar wanderers, but not yet grasp them. We can measure shadows, but not seize substance. Atlas reminded us of the limits of our reach, the fragility of our vision. And yet, within that limitation lay possibility. For the very struggle to study Atlas became a catalyst, the realization that humanity must prepare differently, that the next interstellar visitor must not slip through our fingers. The ghost-like signals may have faded, but their message was clear. The universe is sending emissaries, and we must learn to greet them before they vanish into night. In the aftermath of Atlas's fading trace, astronomers began to dream of interception. The lessons of Oumuamua and now Atlas made it clear, passive observation was no longer enough. Each visitor came and went too swiftly, carrying secrets too vast to be left unstudied. If humanity was to learn from these wanderers, it would need to meet them in space, not just watch them vanish from afar. The conversations turned toward the future, toward the points of quiet balance in the solar system, Lagrange points, where the gravity of Earth and Sun cancel into stillness. These were natural sentinels, cosmic gateways where spacecraft could wait in silence, fueled and ready, until the next interstellar intruder appeared. From there, an interception could be launched in days rather than years, a sprint to catch what otherwise would be lost. Concepts began to take form, probes equipped with high-speed propulsion, lightweight sails driven by sunlight or lasers, compact instruments designed to scan composition, surface, and structure up close. Some envisioned swarms of small interceptors, ready to scatter outward the moment a hyperbolic orbit was confirmed. Others imagined great observatories at these vantage points, staring permanently into the darkness, their sole task to detect the next anomaly before it slipped past. The urgency was not only scientific but existential. For every interstellar object is a messenger, some harmless shards, others potentially catastrophic. A collision with Earth, however unlikely, could carry energies beyond imagination, seeded from another system's chaos. To intercept was not merely to learn, but to defend. Atlas was a reminder that the galaxy is not empty. It is strewn with fragments, some wandering aimlessly, some on paths that may one day cross ours too closely. The dream of interception carried with it a philosophy as well. To chase an interstellar traveler was to admit our place within a cosmic web, to recognize that we are not isolated, not sheltered, but exposed to the tides of a galaxy alive with debris. It was a call for humility and for ambition, a recognition that to understand these visitors is to understand the broader fabric of which we are a part. Plans remain sketches, papers, proposals, yet the seed has been planted. One day, perhaps soon, a spacecraft will rise from Earth and wait at the balance point, listening for the next whisper from the void. And when the next Atlas arrives, humanity may be ready not only to watch, but to reach out, to touch, to finally hold a fragment of the galaxy's endless drift. In the great conversation about interstellar mysteries, one voice carried further than most, bridging science with philosophy, physics with imagination. Michio Kaku, when asked about Atlas, his reflections transcended the ordinary debate of jets, spectra, and orbital mechanics. To him, this object was not just an interloper of ice and rock, but a messenger whispering about the deeper structure of reality. Kaku has long spoken of higher dimensions, spaces beyond the three we walk through and the one we drift in with time. He invokes string theory, with its vibrating filaments of energy resonating across unseen axes, suggesting that what we perceive is but a shadow of a vaster architecture. In the anomalies of Atlas, he found fertile ground for speculation. Perhaps its trajectory was shaped by more than visible forces. Perhaps it brushed against dimensions folded beyond our senses. To many, such thoughts seem poetic, bordering on dreamlike. But Kaku's appeal lies precisely there, in daring to frame physics not only as equations but as story. He imagined Atlas as a hint, a sign that our four-dimensional reality is not complete. Just as shadows conceal the form of objects, the deviations of Atlas might be shadows of higher dimensions tugging invisibly, pulling subtly on its flight. This interpretation resonated not because it provided proof, but because it provided meaning. For if Atlas is indeed influenced by higher dimensions, then it is not merely a comet, it is evidence of the multi-level scaffolding of the cosmos. It becomes a bridge between what we measure and what we cannot yet see, a reminder that our physics may be the local dialect of a greater language. Critics caution against overreach, noting that anomalies often vanish with better data. Yet even they acknowledge that the anomalies of interstellar objects force open doors of imagination. And in Kaku's reflection, Atlas became more than a fleeting speck. It became a question about dimensions themselves, about whether reality is layered, and whether such travelers are the first faint clues of universes folded beside our own. In this way, Atlas was transformed not just into a scientific puzzle, but into a philosophical provocation. It asked not only, "What am I?" but "What is space itself?" The response, carried in Kaku's calm cadence, was as bold as it was humbling. Perhaps Atlas hints that the stage upon which we play is far wider, deeper, and stranger than even Einstein had dreamed. Beyond the comfort of higher dimensions lies a more unsettling speculation, one that threads through the mathematics of quantum fields and the fate of the universe itself. Some physicists wondered whether 3I Atlas might not merely defy gravity, but brush against the most precarious truth of all, the instability of the vacuum. In modern physics, the vacuum is not emptiness. It is a sea of quantum fields, bubbling invisibly with fluctuations, particles and antiparticles flickering in and out of existence. Within this restless background lies the possibility of fragility, the idea that what we call our vacuum state may not be the lowest possible energy configuration. If so, the universe we know rests atop a false vacuum, a plateau above a deeper valley. Should a disturbance trigger the collapse, reality itself could transition to this lower state, rewriting the laws of physics in an instant, erasing atoms, stars, and life itself. Atlas, with its unexplained acceleration, stirred whispers of this theory. Could its anomalous behavior be linked to an interaction with the vacuum field itself? Was it sensitive, in ways ordinary matter is not, to the subtle instability of reality? Such speculation was not mere fantasy. Some models of particle physics suggest that interactions between exotic matter and the quantum vacuum could produce faint, anomalous effects, small pushes, strange deviations. If Atlas carried within it such exotic composition, then perhaps it was a messenger of fragility, an emissary reminding us that the ground beneath physics may not be solid at all. The thought is terrifying. A false vacuum decay would not merely end life, it would end the very framework that defines life, rewriting constants and collapsing chemistry. It would move outward at the speed of light, unannounced, unstoppable. And while Atlas itself posed no such threat, its anomalies echoed this possibility, that the universe is not eternally stable, but balanced on a precipice. For some, the idea was unbearable. too dark to entertain. For others, it was liberating. If the vacuum is fragile, then every moment of existence is an improbable gift, a precarious balance in a cosmos that could collapse without warning. Atlas, then, became more than a rock. It became a reminder of fragility, a wandering symbol of the knife edge upon which reality rests. Theories of false vacuum decay remain speculative, unproven, and perhaps unprovable. But to connect such an idea to an interstellar visitor was to bind the intimate with the infinite, to see in a faint shard of ice and dust the reflection of the greatest cosmic fear, that even the void itself may betray us. Equations are the scaffolding of science, the silent architecture upon which understanding is built. For centuries they have held the sky in place, predicting eclipses, charting the fall of comets, and steering spacecraft with the precision of celestial clockwork. Yet when 3I Atlas was entered into those equations, when its path was mapped through Newton's laws and Einstein's tensors, the results began to fracture. The numbers resisted harmony. Small deviations compounded into stubborn inconsistencies. Orbital mechanics demanded one path, observation revealed another. Chemical models of cometary outgassing predicted thrusts that did not align with measured accelerations. Photometric data suggested a body both fragmenting and enduring, chaotic yet cohesive. Each equation stretched to accommodate the anomaly, and each stretched thin. Mathematics, when tested, reveals its own fragility. For when a model fails, the failure is not merely arithmetic. It is a signpost pointing toward the edges of human knowledge. With Atlas, the models bent, strained, and buckled under the weight of something not yet understood. Was the gravitational constant truly constant? Could radiation pressure, long thought negligible, hide complexities yet unmeasured? Were quantum-scale fields brushing against macroscopic matter in subtle, unexpected ways? Some attempted to force the numbers into familiar frames, adjusting parameters until the fit looked comfortable. Others resisted, arguing that such patchwork was illusion, that Atlas was evidence of physics unaccounted for. To them, the anomaly was not an error to be corrected, but a truth to be revealed. The mathematics, they said, was unraveling not because it was wrong, but because it was incomplete. In this way, Atlas became less an object than a mirror reflecting the limitations of our equations. Each failed attempt at reconciliation deepened the suspicion that something larger was at stake. Not that Newton was wrong, nor Einstein, but that their insights were islands in a greater sea, fragments of a more expansive order waiting to be discovered. And so the scientific community found itself caught between two impulses: to tame Atlas with the mathematics already in hand, or to let it remain wild, an invitation to search beyond the horizon. In that tension lay the true power of the anomaly, for when equations unravel, they do not merely fail, they beckon. In the hushed corridors of cosmology, the presence of 3I Atlas stirred memories of another voice, one that had long warned of the fragility of cosmic order. Stephen Hawking, with his measured cadence and unyielding clarity, often reminded humanity that the universe is not a secure home, but a precarious experiment. His warnings about black holes, about radiation, about the instability of the vacuum echo even now, casting their shadow over Atlas's strange behavior. Hawking had insisted that the laws of physics, though elegant, were not permanent. They might evolve, fracture, or reveal weaknesses hidden beneath their surface. In his later years, he spoke openly of the possibility that the universe itself could be metastable, balanced on a knife's edge. A fluctuation, a disturbance, even the quantum seeds of a fragment like Atlas might expose the fragility of it all. To see an object defy explanation, however subtly, was to confront Hawking's shadow. It was to remember his voice warning that the cosmos, despite its apparent permanence, could unravel. If a single shard from another star system could strain Einstein's equations and Newton's mechanics, then perhaps Hawking had been right. Our confidence in stability is misplaced. His work on black holes also offered a metaphor. Just as the event horizon conceals mysteries beyond reach, so too did Atlas cloak its origins and nature. Its faint light was like Hawking radiation itself, information trickling out from a vast, hidden system we cannot fully perceive. Every flicker in its spectrum, every deviation in its orbit, felt like a coded message from beyond the horizon of comprehension. For scientists watching Atlas, Hawking's presence was almost palpable. His life's work had always circled the unknown, balancing the rigor of mathematics with the humility of uncertainty. Atlas seemed to embody that tension, a reminder that every answer breeds new questions, that certainty is only temporary, that mystery is not a failure of science, but its fuel. Thus, the object was framed not just as an interstellar visitor, but as a philosophical echo. Hawking had left behind the thought that humanity must be ready for truths that shatter its confidence. Atlas, gliding silently through our sky, seemed to test that readiness. It whispered, in its faint and fragile way, that the shadow Hawking cast was not a warning from the past, but a mirror of the present. For more than a century, Einstein's equations have guided the cosmos like a silent metronome. The orbit of Mercury, the bending of starlight, the ripples of gravitational waves, all had confirmed the beauty of general relativity. It was a framework so elegant, so complete, that to question it often felt heretical. And yet, as 3I Atlas carved its puzzling path through the solar system, scientists could not help but wonder, was this the moment when relativity smiled in triumph or frowned in defiance? The object's deviations, subtle but persistent, became a test of the theory's resilience. Relativity does not bend easily. Its predictions have been validated across scales vast and minute. But every theory has its frontier, and Atlas seemed to dwell there, in the uneasy space where equations strain. If Einstein's smile lingered, it was in the realization that even anomalies affirm the necessity of his framework. To notice the deviation is to measure against his law. But if his frown appeared, it was because these deviations whispered of incompleteness, of deeper layers his vision never reached. The philosophical weight of this question was immense. Was Atlas exposing the first tremors of a paradigm shift, the way Mercury's orbit had hinted at relativity itself? Or was it merely an echo of observational limits, noise mistaken for revelation? The community split between cautious patience and daring imagination, each haunted by the possibility that Einstein's legacy was being tested not by black holes or neutron stars, but by a faint shard of alien ice. What lingered most was the tension. If relativity bent even slightly under Atlas, then what came next? Would we be forced to reconcile it with quantum fields at last, to craft a theory of everything more complete? Or would relativity, elegant yet mortal, give way to a successor in the same way Newton had once yielded? Atlas offered no answer. It drifted on, indifferent to the debates it inspired, its orbit a silent provocation. And so Einstein's smile or frown remained suspended, etched not in equations but in the mystery of a visitor that refused to obey with perfect grace. Humanity was left staring at the sky, wondering whether the laws it trusted most were being quietly mocked by a body too faint to see clearly, yet too powerful to ignore. As word of 3I Atlas spread, it did not remain confined to academic journals or observatory logs. The public, already enthralled by the memory of Oumuamua, turned their eyes upward once again. Headlines spoke of a new interstellar messenger, of something foreign and unbound passing briefly through our celestial neighborhood. For many, it felt less like a discovery and more like an encounter with the unknown, with the beyond. Artists imagined its form in paintings and animations, each more speculative than the last. A jagged shard glittering with alien frost, a thin disk tumbling like a broken mirror, or even a silent craft engineered by distant minds. The absence of certainty allowed imagination to flourish. Atlas was not merely a scientific anomaly, it was a canvas onto which humanity projected its oldest longings: mystery, contact, transcendence. For poets and philosophers, the object became a metaphor. Here was a fragment not bound to any star, drifting freely between suns. Was it not, in some sense, like humanity itself, restless, unanchored, reaching beyond the cradle of its birth? Writers compared its fleeting presence to the brevity of life, a reminder that beauty often arrives unannounced, burns briefly in the dark, and departs without explanation. Even among the wider public, a quiet awe took root. Social media filled with questions: could it be alien? Could it hold secrets about other worlds? Why can't we catch it? The scientific community, careful to temper speculation, could not extinguish the spark of wonder. For once, astronomy was not abstract, it was visceral, immediate, and mysterious. There was fear, too. To some, Atlas symbolized vulnerability. If such bodies wander freely between stars, might one someday strike Earth with cataclysmic force? The same imagination that fueled awe also fueled dread. Yet both emotions, the hope of contact, the fear of destruction, sprang from the same realization: the cosmos is not a distant spectacle, but an active place, alive with wanderers that pass close enough to touch. In this way, Atlas transcended science. It became myth, story, symbol, a reminder that humanity, for all its technology and equations, still hungers for mystery. People lifted their gaze, sensing in that faint streak of light a messenger not only from another system, but from the very heart of wonder itself. The fading of Atlas left not only questions but urgency. If the solar system was open to visitors from the stars, then humanity could not afford to be unprepared. Institutions that had once competed for discoveries now began to collaborate, recognizing that the next interstellar object might arrive at any moment, and that this time, the tools to study it must already be waiting. NASA expanded its focus on planetary defense and sky surveys, aware that the same vigilance used to spot hazardous asteroids could also reveal the faint streaks of cosmic wanderers. The upcoming Vera C. Rubin Observatory in Chile, with its vast field of view and nightly sweep of the entire southern sky, was hailed as a sentinel for interstellar arrivals. Its data would not only map countless asteroids, but might detect the next Atlas long before it approached the Sun, giving humanity time to act. ESA too launched projects aimed at tracking interlopers, while independent telescopes, universities, and even amateur astronomers tightened their network. The dream was no longer just to observe, but to prepare missions of pursuit. Concepts for interceptor spacecraft began to circulate. Small probes designed to wait in readiness and launch the instant an interstellar path was confirmed. Some designs relied on solar sails for high-speed chases, others on compact ion drives that could adjust course quickly. The James Webb Space Telescope, though not built for tracking such faint bodies, was imagined as a potential ally, its infrared eyes capable of detecting thermal signatures invisible to ground-based observatories. If pointed quickly enough, it might peel back the chemistry of the next visitor in ways Hubble could not. Technology was rising to meet the mystery, but behind it was something deeper, a shift in perspective. For centuries, astronomy had been passive, waiting for light to arrive. Now, with interstellar visitors becoming tangible, the discipline was turning active, ambitious, restless. The universe was no longer a distant stage, it was entering our neighborhood, and the tools of science had to evolve accordingly. The technological response was not simply about telescopes or spacecraft. It was about readiness, about acknowledging that the galaxy is not quiet and that fragments of other worlds will continue to pass by. Atlas, in this sense, had served as a wake-up call. The message was simple but profound. Be prepared. The cosmos is knocking. Do not let the next messenger slip away. As Atlas slipped further from reach, the battle to interpret it grew fierce. The data was faint, scattered, incomplete, a mosaic of half-seen signals that invited both insight and illusion. Astronomers argued not only about what the numbers meant, but about whether the numbers could be trusted at all. Photometric readings disagreed from one telescope to another, their margins of error swollen by the object's dimness. Some spectra suggested faint carbon compounds, others found nothing beyond noise. Even the measurements of its acceleration varied depending on which dataset was privileged. To some, Atlas was evidence of a profound anomaly. To others, it was little more than the sum of observational limits, a ghost conjured by imperfect instruments. This tension was not new. Astronomy has always balanced on the edge between certainty and interpretation. Neptune was discovered because Uranus's orbit deviated, and the deviations proved real. But Mercury's wobble baffled astronomers for decades before Einstein's relativity resolved it. Other anomalies, once trumpeted, have faded into errors, flawed measurements, faulty calibrations, mirages of noise mistaken for discovery. Which, then, was Atlas, a window into new physics, or another phantom of data? The debates revealed not just scientific caution, but human frailty. Careers and reputations were at stake, each interpretation carrying risks. To proclaim a violation of physics invited ridicule if proven wrong. To dismiss the anomaly risked ignoring the very revolution science seeks. Between those poles, arguments sharpened. Conferences buzzed with competing models, papers contradicted one another, and beneath it all lay the uneasy truth. No one could prove the other wrong because the object was gone. The faintness of the data became its power. In its scarcity, it opened room for imagination, speculation, hope, and fear. Some clung to the numbers as hints of something monumental. Others demanded restraint, warning that to leap beyond evidence was to court folly. But neither side could claim closure. Atlas had vanished into the night sky, leaving behind not answers, but the silence of absence. It was, in a sense, the purest form of mystery, a question without resolution, preserved by the very limits of observation. The cosmos had shown us something, then taken it away, leaving humanity to argue over shadows. Whenever mystery presses too hard against the boundaries of science, a familiar temptation arises, the thought that perhaps we are not alone, that what defies natural explanation may instead be engineered. Atlas was no exception. As with Oumuamua before it, whispers began to circulate. Could this fragment be artificial? Could its acceleration, its strange chemistry, its shape-shifting flicker be the product of intention rather than accident? The idea took root not because of evidence, but because of absence. Jets too faint to see, chemistry that refused to conform, deviations unaccounted for by relativity, each gap became a doorway for speculation. Some envisioned a probe, long dormant, its engines sputtering faintly after millennia of silence. Others imagined a fragment of technology, perhaps a sail once designed to ride the winds of starlight, now broken, tumbling, and decaying as it wandered between suns. The alien hypothesis divided the community. Many dismissed it outright as sensationalism, noting that extraordinary claims demand extraordinary evidence, and Atlas, faint and fading, offered no such proof. To invoke alien design seemed premature, a retreat into imagination when natural explanations still struggled to be tested. Yet even the skeptics admitted the unease. The object's behavior left enough questions unanswered that dismissal could feel as forced as acceptance. And so the possibility lingered, not as consensus but as curiosity. Humanity has always longed for signs of others, and Atlas, with its inscrutable anomalies, fed that hunger. The very act of debate revealed something profound. The boundary between science and speculation is porous, especially when faced with the unknown. What was at stake was not only the nature of Atlas, but the readiness of humanity to confront what it cannot explain. In the absence of proof, the alien hypothesis remained both irresistible and unprovable. It was less a theory than a mirror, reflecting the hopes and fears of those who stared into the dark. For some, Atlas was an engine of awe, proof that intelligence might weave through the cosmos. For others, it was a reminder of caution, that to leap to such conclusions is to risk mistaking mystery for message. And yet, as Atlas receded, the whispers did not fade. They persisted because the object itself refused to close the case. In the silence of its departure, it left behind not only scientific puzzles, but the oldest temptation of all, to wonder whether we had just glimpsed the handiwork of others. The more scientists wrestled with Atlas, the clearer it became that its greatest lesson was not about alien engineering or broken equations, but about fragility. The cosmos, vast and ancient, has always seemed eternal, a clockwork machine running without pause. Yet Atlas suggested something else, that stability itself may be an illusion, that the fabric of reality is more brittle than we dare admit. Its unexplained acceleration, its refusal to fit categories, its alien chemistry, all were reminders that the rules we trust may not be universal. If a single shard, drifting across light years, could defy Newton and Einstein, then what else in the cosmos hides such betrayals? Perhaps matter itself is fragile, its properties mutable under conditions we have not yet tested. Perhaps space-time itself is unstable, bending subtly under pressures we cannot see. This realization cut deeper than the object itself, for if Atlas embodied fragility, then so did we. Our civilization rests upon assumptions, that the laws of physics are fixed, that constants are constant, that tomorrow will obey the same equations as today. To glimpse a body that hints otherwise is to confront an existential unease. If reality can bend, what then anchors meaning? The fragility was not only physical, but philosophical. Atlas reminded humanity that knowledge is provisional, a scaffolding built upon the unknown. Each theory we hold dear may be temporary, each law a local truth rather than a cosmic one. To call the universe fragile is not to diminish it, but to recognize its delicacy, the way galaxies expand into nothingness, the way stars burn out, the way even the vacuum may one day collapse. In this way, Atlas was less a threat than a teacher. It showed us that to live in the universe is to live precariously, balanced on uncertainties we cannot yet resolve. Fragility is not failure, it is the very condition of existence. The interstellar shard, silent and unyielding, became a mirror reflecting our own vulnerability, our own fleeting presence against a backdrop of unstable infinity. And so the object's passage was not only a scientific event, but a philosophical awakening. Atlas had forced us to confront the fragility of physics, of time, of ourselves. And in that confrontation lay both dread and wonder, the recognition that to exist at all is to exist on the trembling edge of mystery. Long after Atlas had vanished into the dark, astronomers were left with one unavoidable conclusion: it would not be the last. The detection of 3 interstellar visitors in just a handful of years suggested that the galaxy is teeming with wanderers, fragments of shattered systems drifting endlessly between stars. Our telescopes, once blind to them, were only now becoming sharp enough to notice. If Atlas appeared in our skies so soon after Oumuamua and Borisov, then countless others must be passing unnoticed, ghosts slipping silently through the solar system. The statistical models were sobering. If even a fraction of interstellar space is seeded with such debris, then trillions of objects, shards of planets, cores of comets, orphaned asteroids must be wandering the Milky Way. Some pass harmlessly through the vast emptiness. Others, inevitably, will cross near Earth. The galaxy is not an empty stage but a restless ocean, and interstellar bodies are its flotsam. This realization shifted astronomy into a new age, the era of interstellar archaeology. Each visitor is not only an anomaly but a sample, carrying within it the chemistry and history of distant suns. Where meteorites once revealed the story of our own solar system's birth, interstellar debris might tell us of countless others, each with its own recipe of matter, its own history of collisions and chaos. Atlas, strange as it was, became the symbol of this new field, a harbinger of discoveries yet to come. But the prospect also carried unease. If interstellar wanderers are common, then so too is the risk of collision. Though the odds of impact are small, the energies involved would be catastrophic, far beyond anything Earth has endured. The same abundance that excites science also stirs fear. The galaxy's generosity comes with hazard, its gifts indistinguishable from its threats. To gaze into this future is to see opportunity and fragility entwined. Humanity may intercept, study, even capture such visitors. They may become stepping stones toward understanding the galaxy, laboratories of alien chemistry delivered freely across space. Yet they are also reminders that we are not shielded, not apart, but immersed in a cosmic current alive with wandering fragments. Atlas, in retrospect, was not a singular anomaly, but a herald. The future belongs to its kin, countless more interlopers, each carrying new mysteries, each challenging the boundaries of knowledge. To prepare for them is to accept that the cosmos is not static but dynamic, restless, alive with travelers that pass uninvited through our sky. The mystery of 3I Atlas did not vanish with the object itself. Instead, it lingered as a question stretched across the horizon of thought. What happens when the laws of physics bend? For centuries, humanity has built its sense of meaning upon the reliability of those laws. We wake each day trusting that gravity will hold us, that time will flow forward, that the constants of nature will remain constant. To glimpse a body that defies those assumptions is to tremble before the possibility that reality itself is less secure than we believe. Philosophers of science have long warned against certainty. Every law is provisional, a scaffold built from observation, destined to be replaced or revised. Yet the cultural imagination often treats physics as immutable, a scripture written into the universe itself. Atlas fractured that illusion. Its anomalies did not only trouble astronomers, they troubled the very idea that the universe is knowable in full. If the laws bend here, where else might they collapse? If one shard of interstellar matter can disobey, then what of entire galaxies, hidden forces, unseen dimensions? The realization unsettles more than physics, it unsettles the human story. For knowledge has always been the anchor of our survival. To admit that knowledge may itself be unstable is to confront the fragility not only of matter but of meaning. Yet there is a strange liberation in this. To see the universe as uncertain is to recognize its openness, its invitation. Atlas does not close a chapter but opens one, reminding us that science is not the conquest of mystery but its constant courtship. Every anomaly is a doorway, every contradiction a horizon. The bending of the laws is not their failure, it is their evolution. In this light, Atlas becomes less a threat and more a teacher. It tells us that certainty is an illusion, that humility is necessary, and that wonder is eternal. The bending of physics is not the collapse of meaning but its renewal, a call to expand imagination, to write new equations, to dream larger dreams. And so humanity is left with a question, not an answer. If the universe itself is unfinished, then what is our place within it? The response lies not in closing the mystery, but in living alongside it, accepting that the bending of laws is the very rhythm of discovery. And then, as quietly as it had arrived, Atlas was gone. Its faint glow diminished until no telescope could hold it. The equations were left unfinished, the debates unresolved, the mystery intact. It drifted outward, beyond the reach of lenses and sensors, returning to the vast anonymity of the interstellar night. What remained was not the object itself, but its shadow in human thought, a trail of questions, a trembling in the fabric of certainty. Its disappearance was not an end but a silence, an unfinished note that lingered in the ear. Scientists turned back to their instruments, but the absence was palpable. Atlas had left behind the memory of defiance, a reminder that even the smallest shard of dust from another star can mock the foundations of physics. Humanity was left with nothing to hold, nothing to test, only the echo of a path carved briefly through the sky. And yet, perhaps this was always the way of it. The cosmos does not explain itself in neat chapters. It offers fragments, glimpses, questions without closure. Atlas embodied that truth. It was less an answer than a provocation, less a body than a mirror. It forced us to look not only outward, but inward, at our hunger for certainty, our fear of fragility, our longing for meaning in a universe that refuses to yield it easily. In the end, Atlas's greatest gift was not data but humility. It reminded us that we are young in the cosmos, our laws provisional, our instruments fragile. The universe is not bound by our comprehension. It flows according to deeper rhythms, vaster patterns, laws still hidden. To accept this is not despair, it is wonder. For in wonder lies the beginning of every discovery, the spark of every question that drives us forward. And so Atlas fades, and we remain, staring into the dark, waiting for the next messenger. Somewhere, another shard drifts closer even now, carrying within it the same defiance, the same silence, the same promise, that the cosmos will never be finished, that mystery will never be exhausted, that every answer is only the opening of another door. The night grows still, and the visitor is gone. In its absence, the sky returns to its familiar constellations, steady and timeless, yet forever changed by what has passed through. Atlas is no longer visible, but its echo lingers not in the stars, but in the thoughts it stirred. What is left is a kind of quiet reverence. To know that interstellar wanderers drift endlessly between suns is to know that the galaxy is alive with motion, its history written not only in stars, but in fragments cast adrift. Each one is a reminder that creation is not neat, that chaos is as much a part of the universe as order. There is comfort, too, in the uncertainty, for if the laws of physics are fragile, provisional, then so too is everything we call reality. Yet fragility is not weakness, it is the condition of existence itself. Stars burn out, planets erode, even the vacuum may tremble on the edge of instability. And still, within that fragility, life blooms, consciousness arises, and meaning is made. Atlas reminds us that mystery is not a flaw in science, but its essence. To lose it into the dark is not failure, but the rhythm of discovery, the fleeting glimpse, the unanswered question, the silence that follows. It teaches us patience, humility, and the courage to look again into the unknown. So let the silence settle. Let the stars reclaim their steady glow. Somewhere in the darkness, another messenger is already on its way. When it arrives, we will lift our eyes once more, and in that act of looking, rediscover what it means to wonder. Sweet dreams.